Cleaner, more efficient, and more deadly. The future of ballistics is here. Largely unchanged since World War I, the bullet now stands to redefine the battlefield and personal defense as we know it. Meet the G9 External Hollow Point. Drawing inspiration from both aerospace and the medical field, this company boasts a projectile that performs like no other. With the ability to smash through hard barriers with consistency and continue on to deliver lethal performance to soft targets, let's discuss the new round you should be carrying and break down the most questioned product in our pro shop. With self-defense or law enforcement ammo, the obvious choice is the hollow point. This design causes bullets to mushroom and stop in soft targets, theoretically eliminating the possibility of collateral damage and delivering a more lethal payload. The downside is that the hollow point will often mushroom in the first barrier it meets, such as a car door or drywall, possibly never getting far enough to reach its intended target. With G9's EHP, you get both collateral damage insurance and lethal blows. But this isn't the only breakthrough G9 has had. With the invite to their facility, Henry and I get the full tour and the lowdown on this exciting new projectile.
Hello, I'm Joshua, the founder of G9. The hallmark of the G9 ammo is that we will shoot through hard things and we'll stop in soft things. There's not a lot of different styles of bullets in the world. When I started, we went to the medical field and to aerospace. We went to different equipment and to different places, and so with that, we can actually shoot through multiple barriers and maintain that shape, and you have a very repeatable, consistent form of creating that trauma. That quality and that consistency that we want goes down to every aspect of what we do, from the machines that we employ to use it and the inspection methods to the people that will craft this ammo. You can't find better performance at a cheaper price. Gentleman, Weston's going to take you on a tour. He'll show you what we do and how we do it and introduce you to some of the people today.
My name is Weston Rogers. I'm the Business Development Director here at G9 Defense. Today we're going to be showing you guys around, showing kind of how the magic is made here.
Where does the process start, Weston?
The process starts actually right here. These are our two priming machines. They run upwards of 150 parts a minute, depending on what we're priming. But the really neat thing about them is, although they run super fast, they keep up in terms of consistency and precision. We even use a more reloader-centric primer upstairs, a Primal Right CPS. It's known to be the best in the industry for getting, perfect primer seating depth. This can run, at 150 parts a minute and still hold those same tolerances. We're keeping within 1,000th on priming, which has a major effect on standard deviations. You can keep that primer depth consistent, you're going to get consistent ignition every time, and we can maintain single-digit SDs. A lot of that is owed to good priming. Collation, getting the cases into the system in the right orientation is kind of the main limiting factor on all things that are involved in mass production loading. So you've got a longer case, say we're priming 375 H&H, that's going to move through that tube slower, and so we have to slow down our run rates on those. Now we're going to where we combine. We've already got primed cases from the priming machine. We're going to combine those with our projectiles. Our projectiles we don't make in-house because the amount of time it takes to produce a Swiss turn, machine projectile versus what it takes to load it. It takes us 35 to 45 seconds to make your average projectile that we use, and we can load 100 in a minute. So we contract with machine shops all over the country. What machine do we have here? What do we got here? This is an Alpha 250. They crank out, most pistol rounds right around 100 rounds a minute. We go to rifle, we get down to about 75, 80, depending on the caliber. Up top, we've got bullets, we've got powder, and we've got primed cases over here. These machines, they have a whole system of checks inside of them. If it fails at any, QC point along the way, it's gonna get kicked out. It's measuring how much powder is in it, so we can actually catch overcharges, we catch undercharges. We're testing along the way the entire time. We're usually testing roughly every 5,000 rounds or every hour, depending on kind of the workflow of the day.
So your powder charge, is it weight or is it time?
We're creating correct powder charge by weighing, what's coming out at run speed. What the machine is doing is using two different lasers to gauge depth. And so, it's not exactly measuring it down to the grain. There's a couple of pistol calibers that we have that by their nature, like 380, they're gonna have a higher standard deviation.
Looks like your average extreme spread on your defensive
average extreme spread, probably 12
feet per second.
We try to keep a tight handle on it. One of the great things about these Alpha loaders is traditional mass production loading machines, you basically have one built line, and that's what it loads. These guys are very flexible. Any of the guys at the shop can change out from 380 to 308, you name it, in a matter of a couple hours.
All right, we got the ammo put together. What's going on here?
Our rounds are generally going to be used for the most important times in people's lives, whether it's for defense, for hunting, you name it. And so going the extra mile on inspection, kind of a great cost to us, but is completely worth it. This machine here is how we inspect everything through. We used to do it literally by hand. As we built up our production, we needed to automate a lot more. This machine has one of the coolest collation systems out there and runs it down that track until we get to this big ramp of cameras and lasers.
What happens in the open airspace there?
It's allowing the laser to see at 360 degrees without obstruction. Basically giving us a three-dimensional readout of everything.
Yeah, I can see you got case length, overall length. That's rad.
Right now we're running 308 with alpha brass, best brass in the world. And so then we can also use this information to diagnose if we're having issues on the loading machines. So not only does it give us an inspection system that doesn't get tired, it runs nonstop, is always dead laser right, but we can also use it as a tool to learn more about how we can be better.
All right, Weston, loaded them up, inspected them. Talk us through what's happening here.
So this is our Hernan waterproofing machine. We waterproof all of our ammunition. So we kind of talked about the benefits that waterproofing has. You know, reduces standard deviation, seals it from the elements. That's the final step in the process. The parts are collated down on the far end, and there's a pair of jets that basically squirt out little drops of this UV Cure sealant. So it shines bright, and actually the computer can tell whether or not it's got a good seal around it.
For both the machine and just visual inspection.
Yeah. Here we can see an example of a reject one that has, see that little glob on
that side of a primer. You got like a half moon there.
Yeah, and so, you know, those little globs can make your gun dirty. Things like sweat, you know, one thing I run into a lot is I carry a Kenai chest holster. In the wintertime, I'm out running around in the snow. By having a sealant, it's just another protection from the elements, just like a sweat guard on your guys' holsters, same idea. The consistency of BC is so much higher because of the machining process. When you're shoving a piece of lead into a copper jacket, you get inconsistencies in density. Despite all best efforts, it's very hard to make those perfect. And through the density of copper being consistent throughout and the machining process, we can keep it 100% of predictable BC.
They come annealed?
They come annealed, yeah.
Oh, nice. For somebody who's wanting to reload, how many times for that 6.5 you think?
As a match shooter myself, I've gotten at least 12 firings on my current batch.
12? Wow, okay.
Yeah, if you treat it nice, it'll treat you nice. When they draw it out initially, they'll anneal the whole piece of brass, primarily focused on keeping that neck soft and supple.
What's next, Weston?
Let's go look at testing. Testing process is happening throughout the loading, but you know we'll show you guys that now.
It's where the rubber meets the road, or the brass meets the ballistic shell. There's something there.
Yeah. So we're out here in the Connex now. This is our shoot lab out behind the building. We do all of our testing in here. We shoot through an AILER 88, which basically is going to get velocities, but then also this connects to our pressure system. So we can be getting, you know, real-time velocity and pressure. And then it's normally connected to a laptop here, and so we can get, you know, real pressure curves and see what's...
You're under Sammy max averages and all that, and that you're not doing overpressure or under for that if you're trying to get, you know, good speeds. So.
Yeah, absolutely. And so, you know, the old school way of doing it would be to kind of try to find safe loads and then basically go off speed. Especially in our rifle ammunition, it's so different than conventional stuff. Going off speed alone would really underutilize these rounds. You know, the driving bands on the side of our projectiles are one of our patented shapes. Kind of ripples that you see on the side primarily are just reducing friction in the barrel. And that also reduces barrel heat and reduces barrel wear. That allows us to run much higher velocities in the rifle stuff while still seeing SAAMI standard pressures.
So you got all the components right there. You guys make it, you can walk right out the back door, test it, walk back in, package it. It's all right here in North Idaho.
Absolutely, yeah. And you know, especially with a manufacturer our size, that's unheard of.
Very state-of-the-art stuff you guys have going on.
We're trying.
I don't think you're trying anymore. I think you're there. Yeah. All right, Weston, you brought us over here to Matthew. Matthew, what's going on here?
So this is a packaging machine I made a few years ago when I was in my freshman year.
You made this.
As a freshman in college?
Yes. And
Whoa.
Okay, I need to up my game. I can make a sandwich.
And so we were buying a lot of machines. That's when we were getting the loaders, the inspection machine. We're automating a lot of stuff in here, and I saw that packaging had not stepped up yet. And so I spent about a week, 2 years ago, trying to come up with a design.
Oh, this just took you a week.
No. But I mean, you know, a week later I called up my dad and I was like, hey, can I work on a packaging machine? And unfortunately, he had already got one. I was like, well, shoot. But he was referring to our other one. I was like, all right, cool. I'll build the cartoning side. And so we've got the tray filling machine that was coming in, and then I decided to take on the cartoning machine. And so I weaseled my way into the machine shop, convinced them that I could call this a class project, and then I was able to use all the fancy tools down at college to build this machine. And then that led to a licensing agreement with Hernan, who's making the waterproofer. And so now for the last year or so, I've been developing a new packaging system that'll do tray tray filling and cartoning all in one that's going to be here for sale within the next year or so.
Wow.
All of our trays are usually stacked up here. They'll come in through the conveyor, and then around here, this is where the boatswain will grab the boxes out of the hopper. And it's named the boatswain because that makes that little blue tube right there the boatswain hose.
Boatswain hose!
It'll grab that, put it into the conveyor, and then as it's moving along, it'll put a tray into it, print a lot number on it, close all the tabs, and out the other side you've got closed boxes.
Do you have any parts named the Nina, the Pinto, the Santa Maria?
I didn't think about that one. But hey, the drawings are not done for this new machine.
You got a P2.
Yeah, this guy right over here. What's cool about this one is that it'll do the tray filling and the cartoning. And so it's really more than twice the machine that one is. And so this is taking our old line that was close to 18 feet long, and we now condensed it down to about 10 feet. It's all integrated, and so really you're pouring buckets of ammo in, you're loading up the trays, you're putting in boxes, and then out the other side of the machine, it's spitting out completed boxes. We're getting everything up to about that 240 to 300 parts per minute mark, which is about what this machine will do. So this one machine will keep up with all 3 loaders.
Wow.
Investors? Possibly you!
So now that we've seen how it's all made, it's time to nerd out on the G9 rounds, starting with the EHP.
Weston, first and foremost, your EHP.
What makes the ideal defense round? It's something that doesn't get stopped by barriers. We see a lot of law enforcement shootings where tons of rounds end up in the car door, that would have been otherwise good shots on the threat.
Because they're relying on expansion.
Exactly.
Beyond something tough like a car door, you can even talk drywall or plywood or something
Absolutely,
like that.
yeah.
There's a lot of failure and hollow points in those sort of mediums.
Yeah, so we want it to go, through something hard, and we want to stop in something soft. And the benefit is what's stopping it is what's creating the wounding. So, it enters soft media and it's going to start pushing fluid out. This number's thrown around a lot, 2,100 feet per second for rifle-like wounding. And what that is it's pushing fluid out at that speed. So you've got, 5.56 FMJ round going at least 2,100 feet per second. You're going to see that rifle characteristic wounding. But through the efficiency of the flutes and the non-compressibility of fluid, it's pushing out at greater than that speed. Being a hard copper or hard brass, it's not going to deviate like you see through windshields at traditional hollow points.
You guys don't do anything with lead. It's all pure copper, pure
100%.
brass, or a combination of the two.
That's correct.
Short barrels, long barrels. How does this external hollow point perform?
So the function of the fluid cast off is going to be linear to speed. But the penetration depth is going to be a function of grain weight and the shape of the front of the projectile. Our 9mm out of a Glock 43, it doesn't need to open up, it doesn't need to change status. So it's still going to create wounding. Granted, as speed goes down, the total wound cavity is going to go down some. Yeah. You're going to get probably an inch of difference in penetration depth from, a 5-inch barrel down to a 3-point whatever barrel,
So stepping up to you guys, your hunting ammunition here, Weston, the reason the ballistic tip came around is to improve BCs versus a hollow point because of the inconsistencies, the air getting in there, whatnot, all those things going on. So this to me, immediately off the bat, I'm like, okay, that is a brass tip.
Yeah, so there's a lot more design that goes on into these brass tips. You'll see that it's a fluted tip and it's going down the length of the hollow point. And that fluted tip is actually slightly angled relative to the twist rate of the caliber. And so when it enters, it's going to be a forcing cone for fluid to come in and assist in expansion. This brass 6.5 round, this is just a hollow point without the tip in it, isn't going to open up. And so those flutes and that forcing cone effect cause these to either expand in rounds like this 375 round or hydraulically fracture in this case. And the hydraulically fracturing basically is going to send out, a 45 to 65 degree cone of brass fragmentation. And so brass and certain types of copper, when they hydraulically fracture, it's not like the tearing you see with like a jacket separation on a traditional bullet, which is, those shards are kind of dull. Hydraulically fractured brass and some types of copper, it's incredibly sharp. And so you get this, razor type cutting and this major forcing cone. And so if you're putting it in the vitals of a game animal, your cutting power has just increased massively and it's really sharp. And so, like archery wounds that bleed so much, when it's cut with that really sharp edge, you don't get a release of thrombin like you do. Thrombin's a hormone that triggers blood clotting. And
scientist over here. There we go.
Yeah, and so and so for the 4-legged critters, we do the Woodsman line.
It's also a very unique looking.
Yeah.
This is going to be more of your deep penetrating round. It's an improvement on a traditional hard cast round where we're getting more wounding because of that parabolic curve on the front. Working basically like a snowplow, again, forcing out fluid at that greater than threshold speed to create even more terminal wounding. You're going to get a long, more narrow wound than the EHP. We've embedded fresh beef knuckles in gel before and shooting through those compared to hard cast. Hard cast tends to kind of go the path of least resistance. Sometimes it'll chip off a corner even and then start tumbling, which creates a great wound, but it doesn't create that penetration that you want when you purchase a hard cast.
For guys hunting in Alaska, like you want something that's not just, you know, buffalo bore lead. Like you don't actually want that expansion. You want penetrating power because they're thick skulls.
So now it is time to put this ammo to the test. We've got some standard defense loads and we've got the G9 stuff. We're gonna compare these side by side in some ballistics gel through some mediums like car doors, plywood, drywall. We'll actually see on the high-speed camera how it stacks up. We've got Weston here, we've got Adam here from G9, and then we'd like to thank Cody from Genesis Arms for coming out. They're lending us their slow-mo camera. We'd also like to thank Sharp Shooting Indoor Range for letting us use this space and come out here and film this, so we appreciate them for that. This is Ordnance Gel. Adam was kind enough to make a whole bunch. This is a great medium, and we're pretty excited to send some rounds to this bad boy. You gotta get a gel slab. The secret ingredient is love.
All right, we're gonna start off the testing with our control. We're gonna use Hornady Critical Defense with their 115 grain FTX bullet. Pretty common out in the market. We're gonna start off with that and follow it up with the EHP from G9.
Now the key reason for this test is to establish a baseline, so that way when we start firing through several different mediums, we're able to compare the difference in penetration or lack of difference depending on the ammunition. Then with the control in place, that'll allow us to look at what's happening when we introduce the barriers to make sure that what's happening isn't just random events.
And I think what we're gonna see here is a perfect opened up, just like you'd put in a catalog round. It's gonna do as performed because there's no barrier there.
Eyes and ears, everybody good? Good. All right.
So it looks like for penetration, we got about 12 inches.
It did what it was supposed to, you know, it expanded. You don't want to go all the way through. That's kind of the whole idea, you know, avoiding the collateral damage. They got this little plastic wad there just to fill the hollow point, essentially. I'm super interested to see if that does anything at all going through some of those denser mediums, which I really don't think it's going to.
And there's one thing that's important to recognize when we're looking at gel shots in general. This isn't exactly a 1-to-1 ratio on a human body, and I think Adam can speak to that a little bit.
Yeah, so we calibrate with the BB. The FBI protocol is to calibrate, and it needs to go about 590 feet per second. And it needs to be able to penetrate 3.75 inches at the maximum, about 2.95 at the minimum. So we're right there.
Oh yeah, so that's your guys' actual test BB in there. I didn't even notice that. Okay, so that's how you guys test the gel before
That's how
you
we calibrate, yeah.
Okay.
But it's important to note, if you get shot with a BB gun that's going that speed, does it break your skin?
No, probably not.
And so
unless very close.
We have to look at these gel blocks as, you know, a representation of something we can use to compare things, but
as close as a 1-to-1 flesh ratio as you can get is this section.
Yep, that's exactly it. And that's why in gel, it's, you know, more desirable to hit that, you know, minimum threshold 16 up to 18, 19 inches of penetration, because that's where it translates to being effective in the real world.
Gotcha.
All right, up next, we're gonna follow up with your guys' external hollow point. I'm interested to see what happens. This is an 80 grain projectile going 1,520 feet per second.
And it's not just the speed that matters, it's the shape of the projectile. You know, we can push things fast and you know, maybe increase wounding compared to an FMJ, but they're gonna increase penetration depth too much and not create that wound.
All right, going hot.
Clear. We got. So that one actually looks like Henry was a little down on it.
I should have squatted down more.
We actually have essentially almost a ricochet up into the next block.
Oh yeah, if you just, want to go to kind of a low position.
Definitely a bigger wound channel.
Yeah, really healthy wound track still, but yeah, let's see if we can get a little bit better representation.
Yeah.
Yeah, I'll just get down a little bit lower.
Honestly, that is, I mean, you can already see the penetration difference was pretty significant.
Going hot. Round 2. Got down a little bit lower here, hopefully give a better representation on what this is gonna look like.
Go for it. Oh my goodness.
That's a big hole.
Kind of tracked into the other guy just a hair, but we can still see broad wounding here and consistent wounding that continues past just, you know, that initial neck. Adam, it looks like it about 18.5 inches on the second shot, and then the one that took the long way.
17.5 on the one on the bottom here. It ricocheted from the bottom, so it slowed down a little bit. But
That looks like you could reload that.
Oh, absolutely. We've done it before as a
pretty nuts.
Kind of a goof.
There's no deformation on the flutes at all.
From what you're used to seeing in ballistics gel tests, to make a wound cavity like that, get that much penetration, and just, you know, look like it was when it was pressed in the factory, that's insane.
And that's because the mechanism is totally different, and that's why we're going to see more reliability when we get, you know, to the
To the
barrier
mediums,
stages,
yeah.
because it doesn't have to change shape.
Most definitely did not.
Yeah, exactly.
Oh Yeah, let's check that one out on the high speed.
Oh, wow. And watch this, the gel goes, boink. Is that the technical term? Boink. Boink. It literally bounces.
Dude, that temporary wound cavity is insane. It almost reaches both ends of the gel.
Yeah, and so what you're seeing on that initial expansion is that temporary wound cavity, and then what's left behind is that permanent wound cavity. And you see that ultimate diameter, what we see, left in the gel block is left in meat or tissue.
See how the front end of the gel pushes out right where the bolt in is?
Yeah.
That'd be a mess.
And so we're seeing penetration depths in that more comfortable range too, or more effective range at 18.5 inches is kind of where you want to see things.
Now with the controls in place, we're going to introduce barriers to see how they stack up. First, we're going to start with the drywall.
Going to shoot the critical defense again. This time we're going to shoot through 2 pieces of drywall and then into the medium. All right, we good? Good. Stand by. It's a lot lower than I thought it was going to be. Yeah. How we do on the gel?
So what we see is it failed to open.
Yeah, it definitely didn't mushroom as much as the last one.
Because that FTX filling in the front, that's designed to prevent it from doing what it just did, right?
Exactly, yeah, it is. And there's 2 factors though. Hollow points can clog and then not open because they're not getting fluid pushed in. But you also have the force on the outside of the hollow point overcoming the fluid that's on the inside to push it out.
We were talking before this, Wes, and you said sometimes you'll shoot it through the drywall and sometimes they'll perform. Sometimes they won't. Looks like mostly a failure to perform here. Yeah. But that's the biggest thing when you're talking about, personal defense ammo, carry ammo. You don't want something that works 90% of the time. Like, there's nothing is 100% reliable, but you want to get as close to that line as you can.
Yeah, and so when we compare it to the control, you see that across all hollow points where they failed to do as they were designed to about 30% of the time. You introduce barriers, that goes up to 50%, 90%, depending on the design.
Well, cool. Let's see it on the slow-mo.
Pretty much acting like a full metal jacket.
Yeah. As soon as that gets clogged, it's not doing what it was designed to do. Will it harm what you're shooting at? Yes, but it's not ideal.
And this one didn't penetrate that deeply. A lot of times you'll see them penetrate, like an FMJ does. So,
smoke right
36 inches. And this one, I think it had a little bit of jacket separation, which slowed it down and actually helped it create some better wound. But again, it's just not working the way it's supposed to.
All right, shooting the G9 external hollow point, 80 grain. Intermediate barrier, drywall, 2 sheets into the medium, the gel. All right, rock and roll.
Stand by. Oh!
You hit what you aimed for this time.
I hit the point of aim, so that was good.
What I'm seeing is the Hornady did really well in its mangled format. We see slightly bigger wounding on the G9 here, especially you can see it laterally from above. But looking at the wound track here, it's the same style of wound track that we had, without a barrier. We're getting roughly the same depth of penetration. I think we lost about an inch there.
It's consistent.
It's consistently performing the same way every time.
It's definitely interesting seeing no intermediate barrier, seeing how the round performs, and then putting an intermediate barrier here, and then seeing how the round performs. I think that speaks for itself because in general, intermediate barriers are going to be consistent with a real life situation.
Absolutely.
And in order to stop a threat, what do? You have to get accurate rounds onto a target with good performance of the bullet.
And let's look at some high speed.
Yeah, that had a decent temporal cavity right there.
Down a little.
Oh,
wow.
Yeah.
Yeah, I see what you're saying, Wes, and it kind of sucks it up.
Yeah, it pulls that drywall through. And that's, it's basically creating a, pressure differential that's going to be pulling media through as it pushes stuff out, and so that's why that drywall dust gets pulled in with it. Another feature you'll see is when we pull that bullet out, it's clean, there's no drywall there. Those flutes are shedding that material as they enter the media or even before.
The wound channels, they're not bad, like they are similar, but you see the hydrostatic shock, like the gel, when you hit it with that G9 stuff, the whole thing moves. So at first glance, it doesn't look like it's all that different. However, the point of the EHP is to be consistent through any type of barrier. So up next, we have something a little bit tougher, a car door. Now, this is one of the most interesting ones here. We have the Hornady Critical Defense again, but this time we're going through a car door. I'm gonna try and not screw this up at 5 yards.
All right, let's see what we got.
Ooh, that looks like that didn't do what we wanted it to do. It did penetrate the car door.
That got pretty funky, didn't it?
Did that fully separate?
Yeah, full jacket separation, then it looked like it turned.
Oh, it went in sideways for sure.
Yeah,
it went in sideways, yeah.
That bullet is completely turned, the lead core has completely separated and continued past. Imagine the windows rolled down, like even not potentially exit the car door.
Yeah, no, I'm sure if you get a little bit more metal in that thing, it's not going far.
What do we got, Adam? Jacket's at 7 inches. And the core's at 8.5.
That's half of what we were seeing, less than half of what we were seeing, and the bullet completely fell apart. Check it out on the slow-mo.
Yeah.
There's even debris that bounced off the front of it.
All the energy was dumped and gone by the time it came.
Yeah, in some ways, the branch bullet stayed together too much. You know, it's.
We're not even going through clothing or anything.
Yeah, absolutely.
We got the G9 EHP now going through the car door. We did flip the gel block around because it had hardly penetrated, and we're down to our last gel block here, so it'll look a little funky when we go down there, but we're gonna see how this goes.
Oh, all right.
Oh!
Smaller exit on the door.
Well, yeah, so that definitely wasn't tumbling coming through. You can just look at the two holes side by side.
Yeah, going through heavy steel like that, it's gonna do a little bit to those flutes.
You can see a little mashing of it.
The wound track's gonna be, you know, if you're filing down those flutes a little bit, you're gonna get a little bit less wounding, a little bit less displacement, and a little bit more penetration. But what we're seeing is it's performing the same way, just in a diminished capacity versus a complete fail, not doing what it's intended to do.
Yeah, no, the consistency has been impressive so far to see. Like, that's, I think, the huge thing you guys obviously harp on, and it's showing itself with every shot we take. Let's check it on the high speed.
Yeah, let's do it. Boom.
Yay.
That is
wound channel.
more impressive than I imagined.
I honestly, looking at it, the temporary cavity looks the same
Yeah.
as the drywall and as the
control.
as the control.
Yeah,
That's seeing it.
I mean, there's already too much to think about in a gunfight anyways,
Exactly.
which is, you know, bore offset, you know, the things beyond, the things in front. You don't want to be worrying about what the bullet's going to do based on the medium that you're battling against.
Yeah, you just want it to do its job.
Yeah, we want to stop the threat, right?
Now we're gonna do the glass, which I'm super interested to see because the deflection that is kind of a known thing, shooting through angled windshields. Weston's told me a little bit about how they've seen theirs perform, so I'm super excited to see how that stacks up.
I got 2 rounds. First, we're gonna do the critical defense from Hornady, and then the next 2 rounds will be G9, the external hollow point. All right, going hot. All right, good to go.
What do we have here?
Looks like we have an extra hole.
Yeah, so I think there was, on the first round of Hornady, there was a jacket separation, which I think is this hole,
Yeah,
and
if I remember right,
maybe
Henry,
this
you
one?
shot 4 times, not 5.
yeah.
Yeah, we have 5 holes. These look like the tumblers. I think the 2 Hornadys here, because you kind of got you got basically the oval shape and a little tumbling here. And then this was probably the jacket separation down here. Versus these 2, you got those perfect concentric, which leads me to believe, and just how that is.
Yeah.
Hornady was on the right, G9 on the left. We've got the 2 perfect holes, so they're not tumbling. You know, that's a super clean entry right there on the bottom one, especially. And we angled the windshield too to simulate an actual car windshield. You were aiming for this dot, correct, Henry?
No, mainly I was just kind of
Using
staying in
those?
frame for the high speed.
okay, yeah.
I wasn't aiming at the center mass at all.
Oh, got it. Okay, I was like, man, that's more deflection than we normally see.
Okay, so for
Yeah, okay,
clarification,
that's better to know.
You
Yeah.
had to get the high speed in frame lined up.
Yeah, if I would have went center mass, it would have been above frame.
Okay, got it.
I mean, you can see it right there. It's once again,
More
it's the consistency.
More reliability.
It's what you're getting every single time. You know what's coming out of that, which is huge. It is the 2 Hornadys first.
Right here.
Oh, wow.
Boom.
Shot straight down.
Yeah, so that was the first one that jacket separated.
I mean, yeah, you can see the debris blast. It just cuts that angle. Just cuts straight down.
Yeah.
You see there's way less glass.
Yeah.
Way
lot
less
cleaner.
glass.
So that was pretty interesting.
Yeah, absolutely. What'd you think?
Seeing is believing. The drywall was a great one there. Like, the Hornady did perform, but sometimes it didn't, depending on the mediums we were going through. The consistency that you guys got in your ammunition, it was super cool to see that it did what you said it would do every time.
And having a projectile, not relying on expansion to deliver that energy. You guys are really onto something.
Yeah, one of the thoughts and perspectives that I share, you know, with the Gen 12, you know, we're shifting a paradigm. If you go back in time with the FBI, they all carried revolvers. Obviously, there's an incident that happens, and they're like, revolvers are not the best gun to have. So they went into semi-auto firearms. You know, there's a shift from 9 to 40. All these things happen in time. You know, we shouldn't be ignorant and dogmatic in these things. We got to be forward-thinking and pushing those envelopes. And as we get wiser as armed citizens and professional users, things change. So why would we not adapt?
So to wrap it up, once again, we want to thank G9 for coming out, you guys. Awesome stuff you guys are doing. We want to thank Genesis for coming out.
Don't be a couch potato. Hit subscribe and like. Don't be pathetic. Let's do this.
Cody's gonna come find you if you don't. And well, I'm standing on a curb, but he's a fairly large fellow.
It's called average.
It's called average.